Hi there! In this video we're going to learn how to make a matrix for use in our analytical work involving 12-tone serial music. Before we begin, let's have a quick refresher on the main ideas of serial music. 12-tone serialism is a compositional technique in which composers derive their music's melodic and harmonic material from a pre-compositional ordering of all 12 chromatic notes. In other words, a particular ordering of the aggregate. Arnold Schoenberg debuted this technique with his Serenade Opus 23 in 1921, and a diverse array of composers continue to write with this method today. The pre-compositional ordering of the aggregate is at the heart of a 12-tone piece's pitch content, and we refer to this ordering as the row. There are many interpretations of what a row does in a piece of music, but for our purposes, the row is the ordered series of pitches governing the harmonic and melodic aspects of a composition structure. Today, we'll be working with the row from Ursula Mamlock's 5 Intermezzi for guitar. Here's the opening of the piece, which states the row in context. We'll spend time elsewhere discovering the infinitely various ways that composers employ the row in composition, but right now we're going to learn to construct one of the main analytical tools theorists use to aid their analysis of this music. This tool is called a matrix, and once completed, it will tell us the pitch makeup of each of the 48 different ways the row can be transformed. You'll recognize the names of these transformations from your previous theoretical studies. Transposition, which we'll label on the row as primary, retrograde, inversion, and retrograde inversion. Our first step will be to copy down our primary row onto the top horizontal row of the matrix. You'll remember this row from our first slide. Our next step is also the most difficult, and it's important that you complete it accurately. We're going to figure out this row's inversion, which we'll copy into the first vertical column of the matrix. To do this, we'll figure out the intervals between each adjacent pitch from left to right of the primary row, and copy it into the opposite direction in our column. To get from our first pitch A to our second pitch C, we ascend a minor third. To get from A to the second pitch of our inversion, then, we need to go down a minor third. A minor third below A is F sharp. Now we will fill in the remaining 10 pitches of the row by repeating this process. I'm going to continue deriving each pitch in detail, but once you feel like you understand the process, I encourage you to pause the video, complete the inversion yourself, and then fast forward to check your answer. Next, we'll look at the distance between our second pitch C and our third pitch D sharp. It's another minor third. So, to get the inversion, we'll want to find a minor third below F sharp. It's D sharp. To get from the D sharp to the fourth pitch G sharp in our primary row, we ascend a perfect fourth. So, we need to descend a perfect fourth for the inversion. That gives us A sharp. Our primary row's next move from G sharp to B takes us up a minor third. So we need to descend a minor third in the inversion. Here's G. Watch now how we get from B to D in the primary row. And from D to A sharp, to get from A sharp to G, we ascend a major sixth. So we'll descend a major sixth to get from G sharp to B. The major sixth from G to E will invert to a major sixth from B to D. And here's our next interval, a major sixth from E to C sharp, And our second to last interval from C sharp to F is a major third, which is going to become F to C sharp in the inversion. Last but not least is the row's only minor second from F to F sharp. That will invert to finish off our row with C sharp to C natural. So, once you've derived the inversion of your primary row, you're ready for the much simpler step of transposing. If you're creating a matrix for which you do not have a convenient video with an answer key, you can still check your answer. If you've made a mistake, it will be apparent because you'll end up with repeated pitches. We have one of each pitch here in our inversion, so we can proceed with confidence. Now we're ready to fill in the rest of our table, which we'll begin to do by transposing our first row up one semitone. This row's official title, by the way, is P9, because it is the primary row beginning with A, pitch class 9, and I've labeled it at the top here. To do this, locate the row that begins with A sharp, P10, a semitone above the pitch that begins our original primary row, A. In a sense, the first pitch of our row was already transposed when we found our inversion. We will now copy down the rest of our row, moving each pitch up a semitone. The second note, C, will become C sharp in our new transposition. We will repeat this process with the third note, D sharp, which will become E in the transposition. And we'll continue moving notes up a semitone with each preceding note, like this. After you've transposed the 12th note in the row, your new transposition will have a complete aggregate. If you have any repeated pitches, something has gone awry and you'll need to recheck your work. We can call this new row P10 as it begins with A sharp. We'll continue this process until each of the 12 pitches has its own primary row. The easiest way to do this is to continue transposing up a semitone, which would make our next primary row begin with B. And this time, we'll move each pitch up from P10 by a semitone, with this result. Notice we're skipping around the matrix a bit in order to have an easy transposition by semitone. If you prefer, you can go from top to bottom, but we'll need to transpose by many different intervals, and this leaves a lot of room for error. To fill in the rest of our matrix, I'm going to continue revealing complete primary rows, going up by semitone, and I'll announce which ones I'm about to show. It would be a great idea to pause the video, complete your own transposition of the rows that I announce, and resume to check your answer. Here's the row beginning on C. And the rows beginning on C sharp and D. Next, I'll reveal the rows beginning on D sharp, E, and F. And finally, the rows beginning on F sharp, G, and G sharp. Notice that once we've figured out all of the primary rows, our chart is complete. By finding these rows, we also name the remaining inversions and the retrograde and retrograde inversions of them. It's important to note the names of the retrograde rows. They keep the same name as the primary or regular inversion row on the opposite side of the matrix. For example, the retrograde beginning on F sharp is called R9 because its associated primary row begins on A. Similarly, the retrograde inversion beginning on C will be called Ri9 because its associated inversion begins on A. We're just about done, but I want to point out one more way to double check your final product. Notice that the A that begins our top row shifts by one cell as it goes down the matrix. This single pitch should end up forming a diagonal line from the top left to the bottom right. And this can be another way to confirm that you've completed your matrix successfully. Finally, I should note that this table of pitch names is not the only way to fill out a matrix. Many analysts replace the pitches on their matrices with the note's corresponding pitch class numbers. This is basically a matter of preference. While numbers have the obvious drawback of looking less like the music, some people find it faster to calculate inversions with a number-based system. Their matrix would provide exactly the same information, but would look like this. I'll be using pitches for my in-class modeling and analytical work. While discovering a piece's pre-compositional organization and its realization in the music is often highly rewarding, remember that highlighting row forms never actually produces a complete analysis of a piece. We'll learn what to do with the information that this matrix has provided us with when we look at movements from Mamlok's 5 intermezzi in class. In the meantime, I encourage you to revisit parts of this video if you feel unsure about any of the steps. Thanks for watching!